Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors as forces. So as per the problem, four forces F1, F2, F3 and F4 are acting on an object and lie in the same plane as shown. The forces F1 and F2 act in an opposite direction. So you can see that F1 and F2 are going in the opposite direction, where the magnitude of F1 equals 30 newtons and magnitude of F2 equals 40 newtons. The forces F3 and F4 also act in opposite directions, with magnitude of F3 equals 35 newton and magnitude of F4 equals 25 newton. If the angle between F1 and F3 is 45 degrees, determine the resultant of these four forces. So in this problem, we have to find the resultant of these four forces, and whenever we have to find the resultant of three or more forces, we should use the component method because it's easier to use. So let's start by preparing a chart for these four forces and writing out the x and y components of these four forces. So for this problem, we'll use the sign convention that vectors acting to the right or in the upward direction are positive. So as a result, vectors to the left are negative and vectors acting in the downward direction are negative. So let's start with F1. So F1 is acting to the right. So that means it has only x component and the x component is equal to 30 newton. And the y component is 0. F2 is acting to the left and it has only x component, its y component is equal to 0. F3 is acting at an angle of 45 degrees to F1 and F1 is horizontal. So we'll have to draw a vector triangle for F3 to resolve F3 into its x and y component. So we can do this here on the side. So we'll have to use a right angle triangle because the x and y components are perpendicular to each other and they'll represent the legs of the triangle. So the hypotenuse in this triangle is F3. The horizontal side is the x component. The vertical side represents the y component of F3 and the angle is 45 degrees. So we have to use SOHCAHTOA to find the x and y components of F3. So we'll start with the x component, and since x represents the adjacent side with respect to the 45-degree angle and F3 is the hypotenuse, so we'll use the cos ratio. So the length of the hypotenuse is represented by the magnitude of F3. And magnitude of F3 is given as 35 Newton. Now we can cross multiply to find the value of x. So I got 35 times cos 45 is equal to 24.75. and the unit is Newton. And F3 is directed to the right side and is also going up. So that's why its X and Y components will be positive. So there's a very important concept you need to understand and memorize. So the X component is 24.75 newtons, and now we can find the Y component, and for that we can use the sine ratio. So the opposite side is the side that represents the Y component, and the hypotenuse is the magnitude of F3. We can cross multiply 35. So I got 24.75. And it'll have a positive value because it's directed in the upward direction. So both X and Y components are positive because F3 is going in the upward direction to the right side. F4 has a magnitude of 25 Newton and it is directed to the left side in the downward direction. So we'll have to draw a vector triangle for it. So this represents F4 and the X and Y components are perpendicular to each other. So it will be a right angle triangle. So the X component will be directed to the left. So it will be negative, and the Y component is directed downward. So that will also be negative. This black angle here will be equal to 45 degrees because this angle and the given 45-degree angle are opposite angles. So we can show that in our vector triangle. And now we can use SOHCAHTOA because this is a right angle triangle. So for the X component, we'll use the cos ratio. And the magnitude of F4 is equal to 25. So I got 17.68. So this is the magnitude of the X component, but we'll assign a negative sign to it because it is directed to the left side. Now we can calculate the Y component and we'll get the same value for Y component because cos of 45 is equal to sine of 45 and the magnitude of F4 is the same and the Y component is also negative. Now we can calculate the total for the X and the Y components for all four forces. So for the X components, we have to do 30 minus 40 plus 24.75 minus 17.68. So I got minus 2.93. And now we can add the Y components. So for Y components, we have to do 24.75 minus 17.68. So I got 7.07 Newton. Now we have to use these totals for the X and Y components to find the resultant of the four forces. So for the X component, we got a negative sum, but for Y component, we got a positive sum. So we'll use the sign to draw the vectors accordingly. Now we have to find the resultant of these four vectors, and we have to use these totals for x and y components. So we'll have to arrange the total for the x and y components in the tip to tail or head to tail format to find the resultant of these four forces. The x component is negative, so that means the sum of the x component is directed to the left side. And the sum of the y components is positive, so it's directed upward. So we'll start the y component sum vector from the head of or the tip of the x component vector, and this is a right angle triangle with the hypotenuse representing the resultant of these four forces. So we'll start by finding the magnitude of the resultant, and for that we'll use the magnitude of the component. So this is the x total and that's the y total. So we'll use the Pythagorean theorem equation. So xt and yt represent the totals for the x and y component. Now we can square these terms and add the result. So I got now we can apply square root to both sides. So I got 7.65. So that's the magnitude of the resultant of these four forces. Now we have to find the direction of this resultant. So for that we'll have to find the measure of this angle theta. And we can use tan ratio. The formula for tan is opposite over adjacent. So the magnitude of the y component over the magnitude of the x component. So the magnitude of the y component is 7.07, and for the x components the sum is 2.93. Now we can do the inverse of tan. So I got almost 67.5 degrees. So that means the resultant of these four forces is, so we'll start with the magnitude. And the direction is 67.5 degrees from F2 towards F3, because F2 is directed to the left side. So this should be the final answer for this problem. So as you can see, so let me show it to you in the given diagram. So vector R, the resultant, is directed somewhere here. So it makes an angle of 67.5 degrees with the vector F2 or the force F2. So from F2, it is directed towards F3, not F4. So this is a very important concept you need to understand and memorize. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.